Hello, let's talk about our three rigid transformations in mathematics, which are reflections, rotations, and translations. They are called rigid because rigid means they keep the same shape and size. Reflections just change orientation, they flip. Rotations just change orientation of an object by rotating it around a point. And translations slide an image, so the size doesn't change, the shape doesn't change. There is a fourth transformation we will talk about later in this class, which is called a dilation. It's a shrinking and growing of an object, which is not considered a rigid because it does change the size of the object, but the shape stays the same. So these are the four transformations, really, that allow us to move objects and ultimately move points around on a plane or a coordinate plane. They also are reasons why we get to see images like this, like say Mario Brothers, for example, how Mario can just kind of slide around the screen, and we have in here reflections. We have when he turns around. We also have his path that we can model mathematically. We can rotate these images and whatnot. So because of these transformations, they allow us to do graphics on video screens and whatnot. Okay, so in this video, you will be learning how and reviewing, if you don't already know, the properties of reflections. We're just going to focus on this one transformation for right now, reflections. So you'll learn the properties of them, or review it from last year. You'll also learn how to construct a line of reflection, how we do that geometrically. Okay, your responsibilities while you watch this video. It is your responsibility to make sure that you take notes. This information is given to you. You must be a student and take some notes on it. Okay, make sure that you come back to these videos if you need to for information. So we will be building on these notes and these ideas through activities. If there's something that you're missing but you remember hearing it back in a video, just go back, find where it's at, take the notes down, and you can do your activities you're doing. Okay, so make sure that you're being responsible. Okay, just a thought for this class. To truly learn something, you must apply it. Alright? But most importantly, you have to apply yourself. You have to try, you have to work. Make sure that you watch these videos, you take notes when you need to, and you perform the activities so that you can show that you're understanding the mathematics. Okay? So let's get started here. Let's take some notes here on reflections. So of our three rigid transformations, we're going to talk about reflections here. Okay? There are two properties of reflections, and we're talking about when you reflect a point. If we talk about images or we talk about shapes, they're just a whole bunch of points, like an infinite amount of them, that are getting treated in the same behavior. So when we talk about one point, we can generalize the figures as well. So one of the first properties of reflections is that the pre-image point, the point that we start with, hence pre, and the image point. The image point is the point that is getting reflected. They're going to be equidistant from the line of reflection. So when you reflect a point or an object, you have to have a line to reflect over. And all these points, consider these maybe like this left triangle here. That's our pre-image. And then after we reflect it over the line, here's the image of it. Okay, and these points are equidistant from the line of reflection. Same deal here, just a vertical representation. The second property is that the line of reflection and the segment that contains the pre-image and image points are perpendicular to each other, which means that they meet at a 90-degree angle. So geometric notation here, pre-image points we use capital letters. The image after we transform the point, this is true for not just reflections but the other rigids and dilations. The image point has a prime notation on it, so it tells us what point we started with and what point got transformed to. Okay, so here would be the line of reflection. It's 90 degrees or at a perpendicular relationship to this segment that connects the two pre-image and image points. Okay, Stop this video when you need to catch up on notes, and then just keep playing it. This is at your pace. Figure out a system that works for you. So make sure that you get these notes down. Okay? Alright, now how to construct a line of reflection. Oops. How to construct a line of reflection here. Last year in Math 1 we did a bunch of constructions. If you don't remember, these are some notes here for you. So step 1, what we have to do is have a pair of points here, which we'll call a pre-image and an image pair. Maybe one is a point, the other one is its reflected point, and we need to find that line that reflects these points onto each other. Okay, so to do that, what we need to do next then is visually see the segment that connects the 2 points. That's really like our visual distance between these 2 points. So to apply our properties of reflections from before, we need to draw a line or construct a line that is guaranteed to be equidistant to the endpoints and perpendicular to this segment here. So to do that, what we do is we create a circle that is centered around one of the endpoints. Doesn't matter which one we start with. Okay, so here's a circle that is centered around one of the endpoints, like the pre-image point here. And we create a radius that is longer than the midpoint, or longer than halfway of the segment. That way we can get some intersecting circles. Okay, so step 4 then is we have to make sure that we keep the exact same radius. That's key to this construction here to make a line of reflection, because it's all about symmetry in reflections. We create another circle that's the same exact radius. So these 2 circles we constructed are what we call congruent, the same shape. And then once you do that, then you just connect the 2 intersecting points of the circles here, and then you make a straight line that goes through those 2 points, and that straight line will be our line of reflection. So those are the 5 steps that we follow when we want to construct a line of reflection. So make sure you get that down in your notes as well. Okay, so let's just talk about labeling diagrams, and that'll be it for the notes here. So here's a diagram, and it's got our labels showing the 2 properties of reflections here. You see that the 2 halves of the segment, now that we have that line of reflection drawn, we have 2 halves here that are of same length. They're congruent halves, meaning that this point H is equidistant, or the same distance to the line of reflection as its image point H prime here. So we denote that with these little marks here that we put on the segment. They go through the segment. That just denotes that whenever you see that, those segments then, those halves right here, are congruent to each other. Okay, and also to denote 90 degrees, we show this little box that shows a 90-degree angle. It actually makes a square. And we know in a square all the angles are 90 degrees. So this square here, I don't know if you can hear my son. I'm almost done here. Hey. This square here denotes a 90-degree relationship. So it's showing perpendicular relationship, hence 90 degrees, and equidistant, meaning we have 2 congruent segments, or the points are the same distance away. Okay? If I were to connect radii here at those intersection points that we constructed of those 2 circles, if we were to draw these radii of the circles, like from center to point on circle, is what we call the radius. And same deal here, this segment here goes from center to point on circle, so it's a radius. And because we know that they're from the same circle, same radii, same circle, we know that they have to be congruent to each other. So I'm just going to show that with their congruent mark. Now over here in our construction, this circle is congruent to this circle. We made it that way. So we know that the radius of this circle, which is also congruent to the radius of this circle, right? They have to be the same length. But they're also congruent to these 2 radii because we made it that way. So I'm going to just show it by drawing our congruent marks through the segment. And then to show that perpendicular again, I'm just going to draw that little 90-degree box right there. Okay? And then also if I want to show that we still have equidistant, now I want to show that this segment is congruent to this segment. Because they're different in length though from these other 4, we're going to just add another little congruent mark to denote the difference. Okay, so that's how we label congruent and perpendicular on diagrams. So I hope that went well. Take the notes, go back whenever you need to, and submit this quest to show me that you understood this. Thanks, guys.